Hello everyone. Today I'm going to share our upcoming professional certificate program on carbon capture, utilization and storage fundamental from fundamentals to industrial plant design to empower corporate teams for energy transition. So this professional certificate program will start on March 24, 2026. This program is for 9 weeks. It will be in live online, and the schedule is Tuesdays and Thursdays from 8 p.m. to 9:30 p.m. Indian Standard Time. So total it will be 18 sessions of 1.5 hours each. So let me explore about ORB Cleantech. ORB Cleantech supports industrial organizations, engineering teams, sustainability leaders, and climate tech professionals in improving technical and investment decisions making for low carbon technologies. We specialize in CCUS, hydrogen system, and industrial decarbonization. Our focus is delivering practical, decision-ready insights that connect engineering science with commercial execution at the intersection of technology evaluation, process engineering, and business strategy. Our approach, using robust techno-economic frameworks to evaluate CCUS and hydrogen pathways, identify integration challenges and project risk early, and translate complex technical choices into actionable strategies. Our impact, providing capacity building through specialized training program, corporate workshop, and executive seminars to strengthening internal technical capability and uh, improvement readiness. We help organizations move from concept to implementation with confidence, aligning engineering discipline for long-term climate and sustainability goals. About the certificate program on CCUS, this comprehensive professional certificate program on CCUS is designed to provide strong technical knowledge, practical industry exposure, and applied engineering skills in a critical technology driving global decarbonization. It is tailored for working professionals, engineers, researchers, consultants, and decision makers seeking an end-to-end understanding of the CCUS value chain. The course begins with foundations in climate change, energy transition, and the strategic role of CCUS, covering global and regional initiatives, policy frameworks, and investment trends shaping the low carbon economy. Participants gain clarity on why CCUS is becoming central to net zero strategies across heavy industries. A major component focuses on carbon capture technologies, including pre-combustion, post-combustion, and oxy-fuel system supported by case studies. The program also includes design of CO2 capture plan covering process flow diagram, solvent selection, absorber stripper configuration, equipment sizing concept, energy integration, utility needs, and performance indicators, linking theory with real engineering practice. The curriculum further explores carbon utilization pathways in chemical, biological, and mineral routes, and carbon storage technologies, including geological storage, monitoring and verification, management, and regulatory aspects. Participants Participants also gain insight into CCUS project implementation, from feasibility and techno-economic assessments to cost implementation and project planning, supported by interactive workshops. Advanced sessions address policy, legal and economic frameworks, emerging technologies, and career opportunities in CCUS, enabling to position themselves effectively in the growing decarbonization market. Overall, the program builds well-rounded CCUS competency, technology, plan design, economic policy and execution for professionals aiming upskill sustainability initiatives. Who will benefit? Graduates and students, engineers and energy engineers, consultants and managers, environmentalists and environmental managers, energy auditors and energy managers, carbon auditors and ESG professionals, sustainability and CSR professionals, energy management professionals, or anyone interested in carbon neutrality and greenhouse gas management. So the learning objectives are understanding the role of CCUS, comprehend the importance of carbon capture, utilization and storage in mitigating climate change and its role in global and regional policies, net zero strategies and industrial decarbonization pathways. Master carbon capture technologies. Identify, compare and explain major capture routes including pre-combustion, post-combustion and oxy-fuel combustion and emerging capture materials and processes. Engineer and design CO2 capture plan. Develop fundamental engineering design capability including process flow diagrams, basic equipment design, absorber stripper configuration, solvent choice, heavy heat integration concepts, utility estimation and performance indicators for a capture facility. Explore carbon utilization pathways, evaluate chemical, biological, mineral utilization option, etc. Implement carbon storage solution, understand geological storage method, site screening criteria, monitoring and verification techniques, risk assessment, safety considerations and regulatory requirements for secured CO2 storage. And then plan and execute CCUS projects. Apply skills in projects scoping, feasibility studies, techno-economic assessment, cost integration, cost estimation, infrastructure planning and implementation road mapping. Engage in practical application. Participate in hands-on exercises and group activities in conceptualizing and present basic CCUS project designing, including technology selections and site suitability evaluation. And stay updated with advanced CCUS technologies in terms of what is happening, enhanced storage techniques, digital monitoring tools, current R&D trend, etc. Analyze economics and policies, then identify future trends and career opportunities, very interesting it will be. Recognize the CCUS integration and renewable energy and hydrogen systems, emerging market needs and the competencies required for future CCUS technologies for the CCUS professional. Collaborate and communicate effectively. The agenda in session 1 will explore the introductory things, then importance of CCUS for mitigating climate change. Session 2 will explore global and regional CCUS initiatives and policies. Indian government's rupees 20,000 crore investment in CCUS, how it will affect the industry. Then different carbon capture technologies will be covered in session 3 and 4. Session 5 is booked for CO2 compression and transportation. We'll take session 6 and 7 for geological storage of CO2. Session 8 and 9 will be for CO2 utilization and CCS in chemical industry. Session 10 will be dedicated for CCUS in power sector. Session 11 will be CCUS for cement industry. Session 12 will be CCUS for steel sector. Session 13 will be CCUS in refineries. Session 14 will be dedicated for CCUS cost calculation and project implementation. Session 15 will be economic policy and legal regulation. Session 16 and 17 is dedicated for carbon capture plant design, and finally session 8 is dedicated for CCUS safety, risk assessment, career opportunities, etc. So the program director is Dr. Ujjwal Kumar Ghosh, myself. I am a professor at Haldia Institute of Technology and founder and managing partner in ORB Cleantech Inc. So I did my chemical engineering in Calcutta University, BTech, then masters and PhD in chemical engineering from IIT Kharagpur, and after that I went to University of Melbourne, Australia. As a postdoctoral fellow, I worked with CO2 capture project in the lab. We have developed pilot plan. We run optimized a pilot plan for carbon dioxide capture, and the project was funded by Cooperative Research Center for Greenhouse Gas Technologies, that is CO2 CRC. After that, I have worked in countries like Malaysia, Qatar, China, and India in different capacities. And the last is the link for enrollment for this course.